Section 2.4, solving compound inequalities. Compound inequalities use the word and the word or. We're going to look at using the word and first. We're going to solve and graph. And when it says the word and, that means we're going to graph them on the same number line. Well, with the word or as well. So first, looking at the first one, I'm going to divide both sides by 3, and that gives me x is less than 4. Second one, I need to subtract 1 first. That gives me 2x is greater than negative 6. Divide by 2, both sides of the inequality symbol, and we get x is greater than negative 3. So now I need to graph those, and I can graph them on the same number line. Draw out my number line first. So for the first one, I look at where's x is less than 4. There's no equal sign, so again I'm going to use my parenthesis. And then before I shade it, I'm going to look at the second one. X is greater than negative 3. Again, no equal sign, so I use parenthesis. And then I shade in between the two. Because of the word and, I know that I am going to have my graph included between the two sets of parentheses. So all the solutions between these two sets of parentheses will make both of those inequalities true. The word and means we need to include both. Only those values for both inequalities. Another example using the word and. 1 minus 2x is greater than or equal to 0, so I'm going to subtract 1 from both sides. Gives me negative 2x is greater than or equal to negative 1. Divide both sides by negative 2, and remember we're dividing by a negative, so therefore we must turn that symbol around, and that gives us positive 1/2. On the other side, I subtract 7 from both sides. Gives us 2x is greater than or equal to 4. Divide both sides by 2. We're dividing by a positive, so in this case we do not switch that symbol around, and we get x is greater than or equal to 2. So to graph this first one here, I am going to find 1/2, it's about right here, and x is less than or equal to that 1/2, so I'm going to use my bracket and shade this side. And then I'm going to graph my x is greater than or equal to 2. Again, because of the equal sign, we use a bracket, and we shade this side. And notice there is no overlap at all. The word and means to find all solutions that make both inequalities true. Since there is no overlap, that means there is no solution. Let's look at an example using the word or. With the word or, we are finding solutions that will either make the one inequality true statement or the other. So now it's okay if there is no overlap because of the word or. So let's solve for x. Subtract 7 from both sides. Gives us negative 3x is greater than or equal to negative 6. Divide both sides by negative 3. Again, remember, we are dividing by a negative, so we turn the symbol around. And that gives us x is less than or equal to positive 2. On the other one, we subtract 2 from both sides, and we get 5x is greater than or equal to 20. Divide both sides by 5. Again, we're dividing by a positive, so we do not turn the symbol around. And that gives us x is greater than or equal to 4. Now we're going to graph both of those. First I'll graph x is less than or equal to 2. So because of the equal sign, remember, use the square bracket, shade the rest of the graph. Now I will graph x is greater than or equal to 4. Again, square bracket because of the equal sign, and I shade the graph. It is okay to have the split. So the solution then can be written as negative infinity, comma, 2 for the first one, and 4, comma, positive infinity for the second one, and then we join them with a U, meaning union. Our solution is the union of those two intervals.